Here's your assignment on practicing graphing reciprocal functions. So the first thing I'm going to write down is what h equals. There's no adding or subtracting in the denominator, so h is 0. I'm going to do this so that I can have room. All right, so h is 0, k is 3, and a is negative 2. So that negative belongs to the 2. So what is our vertical asymptote? It's x equals 0, what h is. Our horizontal asymptote is y equals 3, what k is. The points that we're going to change are 1, 1, and negative 1, negative 1. So if I take 1, 1, to the x, I'm going to add 0, so it stays the same. To the y coordinate, I'm going to multiply by negative 2 and add 3. So 1 times negative 2 is negative 2, plus 3 is 1. It's actually stayed the same. So the x is going to stay the same when you add 0. The y coordinate, negative 1 times negative 2 is 2. Add 3, and it's 5. So we're now ready to graph. So I'm going to start with the asymptote. So at 0 and at 3, we have 2 points to put on here, which are 1, 1. Notice there's a reflection, and negative 1 and 5. So now this point that would be above is now below. So the graph is going to go to negative infinity and then curve up. On the other side, it goes to infinity and then curves down. If I ask you for the domain, x cannot equal 0. If I ask you for the range, y cannot equal 3. And if I said the end behavior, as x approaches infinity, the function approaches 3. As x approaches negative infinity, the function approaches 3. So both the right end and the left end are approaching what k is as your end behavior. Number 2. So again, my suggestion is for you to try it and then press play. Or if you get stuck, play to the point where you need help and then press pause again. H is 0, k is 2, and a is equal to 3. That means the vertical asymptote is at x equals 2, and x equals 0, The horizontal asymptote is at 2. To change the points, 1, 1, and negative 1, negative 1, the h changes the x, so that means it doesn't change when you add 0. The k, we're going to multiply and then add. So 1 times 3 and then add 2. We're going to do it again. Negative 1 times 3, negative 3, plus 2. And we're going to put those points on. So we'll start with the asymptotes. So that's at 0 and 2. The points are at 1, 5 and negative 1, negative 1. And then draw the curve through the points. The domain, x cannot equal 0. The range, y cannot equal 2. And then the end behavior. So as x approaches infinity, the function approaches 2. As x approaches negative infinity, the function approaches negative 2. So it always goes with the horizontal asymptote or what k equals. Oh, did I say negative 2? This should be positive 2. There it is. All right, number 3. Press pause and try it, and then I'll do it. So h is negative 1, k is 2, and a is negative 4. So the vertical asymptote is at x equals negative 1. The horizontal asymptote is at y equals 2. And then we're going to change 2 points and put them on our graph. So to change the x, the h is what changes the x. So 1 take away 1 is 0, and negative 1 take away 1 is negative 2. For the y coordinate, I need both numbers, so I'm going to multiply and then add. So 1 times negative 4 is negative 4, and then add 2. That's negative 2. Negative 1 times negative 4 is positive 4. add 2, and it's 6. Recognize there's a reflection here because A is negative. So our asymptotes are at -1 and +2. So we have 1, 1. Sorry, 0. Where did I get 1, 1? 0, -2, I mean. So 0, -2, and -2, 6. And then I'm going to use these, not this one, this point, I'm going to curve. So because of the reflection, the right side goes down forever and then curves up. This one goes up forever and then curves and joins the horizontal. So those are the two curves. Again, the domain restriction, x cannot equal what h is, which is -1. The range restriction, y cannot equal 2. And then the end behavior, as x approaches infinity, the function approaches the horizontal asymptote, which is 2. As x approaches negative infinity, same thing. The left end behavior also as it approaches 2. All right, number 4. All right, press pause and graph it, and then press play. So did we get H, K, and A correct? The vertical asymptote is at 0, and the horizontal asymptote is at -2. I'm going to change 2 points to put them on my graph. So I'm going to, 0 means the x stays the same. A, I multiply, and K, I add or subtract. So 1 times -2, take away 2 is -4. -1 times -2 is 2. Take away 2 is 0. All right. Asymptotes. Points. I keep doing that. I go right to there instead of here. So 1 and -4. Or -1 and 0. Notice the reflection and what it does to the curve. So curve, you should be now more and more comfortable with the curve of a reciprocal. The domain restriction, x cannot equal 0. The range restriction, y cannot equal -2. And the end behavior. So both the right end and the left end go to K, the horizontal asymptote, which is -2. Number 5. Press pause and do it, then press play. So the vertical asymptote is at -2 and the horizontal asymptote is at 1. We have 2 points to change. So for the x, I'm going to subtract 2. So -1 subtract 2 is -3. To the y coordinate, I'm going to multiply and then add. So 1 times -3 and then add 1. -1 times -3 is +3. Plus 1 is 4. Notice again, A is negative, so there is a reflection. I'm going to graph this now. So we have an asymptote at -2. We also have one at +1. And then plot the points. So -1, -2, and -3, and 4. And then draw the curves. Beautiful. Number 6. Oh, I forgot this, right? The domain, x cannot equal -2. The range, y cannot equal 1. And then the end behavior. All right, on to number 6. You first. Press pause. So the vertical asymptote is at x equals -1, and the horizontal asymptote is at y equals +1. We're going to change 2 points. So the h is negative 1, so 1 take away 1 is 0. Negative 1 take away 1 is negative 2. The y coordinate, we're going to multiply and then add. So 1 times negative 3, and then add 1. And then negative 1 times negative 3 is positive 3, add 1. And now this is what we're going to graph. So at negative 1 is the vertical asymptote. At positive 1 is the horizontal asymptote. The points are at 0, negative 2, and at negative 2 and 4. So there's a reflection. So then draw the curve through those points. Now write down the domain restriction. So x cannot equal negative 1. The range restriction, y cannot equal 1. And then the end behavior. So as x approaches infinity, the function approaches 1. As x approaches negative infinity, the function approaches negative 1. Beautiful. All right, let's practice this. So I'm going to just draw some lines to help organize my work and go from there. So h is 2, k is 2, a is negative 3. That means the vertical asymptote is at x equals 2. The horizontal asymptote is at y equals 2. And we have 2 points we're going to change. So the h is 2, so I add 2. The k is negative 3, and then I add 2. So 1 times negative 3, add 2. That's negative 1. Negative 1 times negative 3 is 3, plus 2 is 5. And that's what I'm going to graph. So we'll start at 2. And 2. The points are 3, negative 1, and 1 and 5. And then draw the curve through those points. And there you go. For number 8, I didn't do this right. I got to finish this. Domain, x cannot equal 2. And the range, y can't equal 2. And the end behavior. So as x approaches infinity, the function approaches 2. As x approaches negative infinity, the function approaches 2. So you have that. Number 8, you first. Press pause. So again, I'm going to go quickly because you've had a chance to do it first to make sure that you did it correctly. So the vertical asymptote is at x equals negative 2, and the horizontal asymptote is at y equals 2. The 2 points that we're changing are 1, 1, and negative 1, negative 1. So for 1, 1, we're going to subtract 2, and then subtract 2. For the y coordinate, we're going to multiply and then add 2. So 1 times 4 plus 2. Negative 1 times 4 is negative 4 plus 2. And those are the points and the asymptotes that I'll put on my graph. So at negative 2 and at y equals 2, the points are negative 1, 6, negative 3, 2, negative 2, and then draw the curve that goes through those points. And then the domain restriction, x cannot equal negative 2, and the range, y can't equal positive 2. And then the end behavior, as x approaches infinity, the function approaches k, which is 2. As x approaches negative infinity, the function approaches again 2. So both the left end and the right end behavior approach the asymptote. All right, 4 left. All right, press pause. You practice. When we practice, this is how you learn it. Now press play. Let's see if we did it correctly. Are we getting stronger with this? Is it getting easier? For most of you, you've never done this before, so that's why we're practicing so much, so it gets easier and easier. So notice the asymptotes, the points, are they matching? So I'm going to add 2. I'm going to multiply and then subtract 2. So that gives me negative 6, positive 4, take away 2. So that's what we're going to put on my graph. So we have 2 and negative 2. The points, 3, negative 6, and 1, 2. And that those are the points I'm going to curve through. So there's my graph and what it looks like. The domain, x cannot equal 2. The range, y cannot equal negative 2. And then the end behavior. So the end behavior is going to negative 2. Done. All right, number 10. Again, press pause. You first, then press play. So this is what I got. Negative 2, positive 2, and again positive 2. That would mean the vertical asymptote is at negative 2, and the horizontal asymptote is y equals positive 2, and then we change the points. So to the x, I subtract 2. To the y, I'm going to multiply and then add. So that's going to give me 4, and that's going to give me 0. Put that on my graph. And then take the points and curve them. The domain restriction, x cannot equal negative 2, and the range, y cannot equal positive 2, and the end behavior, as x approaches infinity, the function approaches the k value 2. As x approaches infinity, the function approaches again to negative infinity. All right, 2 left. Again, number 11, you first, then press play. All right, this is what I got. Negative 2, k is 0, and a is 3. So the vertical asymptote is x equals negative 2. The horizontal asymptote is y equals 0. The points are 1, 1, and negative 1, negative 1. Change them. The h is negative 2. So I'm subtracting 2 to the x coordinates. The y coordinates, I'm going to multiply. Adding 0 does nothing, so I'm just going to multiply it times 3. And then I'm going to put those points down. And the asymptotes. So negative 2 and 0. Then I'm going to plot. So negative 1, 3. And negative 3, negative 3. And then draw the curve. So there's your graph. Try not to make it, doesn't curve up, right? So it curves along it. So make sure that when you draw it, it's going to go right beside it and not curl back up or curl back down. The domain restriction, x cannot equal negative 2, and the range restriction, y cannot equal 0. And then the end behavior, as x approaches infinity, the function approaches 0. As x approaches negative infinity, the function approaches 0. Last one. Here we go. You first. So press pause and do number 12. All right, this is my answer. H is negative 2, k is 1, and a is 4. The vertical asymptote is x equals negative 2, and the horizontal asymptote is y equals 1. The 2 points that I'm changing are 1, 1 and negative 1, negative 1. I'm going to multiply, I'm going to subtract 2. And then I'm going to multiply and then add. So that's 4 plus 1 and negative 4 plus 1. And that's what's going on my graph. So negative 1 and 5, and negative 3, negative 3. And then draw the curve that goes through these points. The domain restriction, x cannot equal negative 2 in the range, y cannot equal 1. And lastly, the end behavior. As x approaches infinity, the function approaches the k value, which is 1. As x approaches negative infinity, the function approaches also 1. Left and right, I am so proud of you for doing your work. Mr. G Math, over and out. Till next time.